As a boy growing up here in Weston, Connecticut, I spent a lot of time on the Aspetuck River and the Saugatuck River fishing, and had a little Boston whaler out on the Sound doing fishing, camping, water skiing, and so forth. So this topic is really near and dear to my heart. I love all water and all nature, but this one really hits home. And the topic of our conversation is the ecological restoration in the Long Island Sound region. And more specifically, ecological restoration that has been done or is being done or is planned to be done by a great organization called Save the Sound, based here in New Haven, Connecticut. For those of you that are not familiar with Long Island Sound, it's a tidal estuary. It's between Long Island, New York, to the south, and Connecticut to the north. It's about 120 miles long, and at its widest point, it's 21 miles in width. It's fed by freshwater tributaries and the Atlantic Ocean, salt water from the Atlantic Ocean. So it's got a mixture. It's a really precious estuary for a lot of natural species. So I'd like to introduce our guests from Save the Sound. We have Gwen McDonald. Gwen is the director of green projects and restoration at Save the Sound. And we have Alex Crofta, the ecological restoration projects manager. And I had the opportunity to meet Alex about a year ago at a Patagonia event, Patagonia store in Westport, Connecticut. Future Frogmen is actually partnered with Patagonia, and Save the Sound was there. I joined Save the Sound that evening, and we saw a screening of a wonderful Patagonia film called Blue Heart, which I'd highly recommend. I noticed that it is now available on YouTube, so you can see the whole film there. And it's really about wild rivers in Eastern Europe and the associated cultures and ecosystems that are threatened by approximately 3,000 hydropower plants there. It's really an excellent film, and it talks about the value of preventing dam construction and taking dams down, how that can impact favorably or negatively, depending upon the scenario of what's going on there. So one of the things we're going to talk about tonight is dam removal and the work that Save the Sound does on that, as well as other ecological restoration projects that they work on. I recently had the opportunity to meet Gwen as well, having met Alex a year ago, recently met Gwen, and really just so impressed by both Gwen and Alex that I asked them if they would be my guest. So with that, I'd like to ask you, Gwen. I noticed that you've been with Save the Sound for about 10 years now, initially overseeing restoration projects, and now you're, looks like you're overseeing the entire program, kind of from soup to nuts. So could you tell us more about, maybe starting with your background, your education, and how your career has evolved?
Yeah, sure. Thanks, Richard. That was a wonderful introduction to the sound, and I really appreciate it. It's an interesting place to be, and it's been fun to work on projects for 10 years now. So I have been sort of living and playing in rivers for for a really long time, since I was a very little kid. Actually, up in the picture in the background of my Zoom call right now is up in the Adirondacks, and I spent a lot of time there as a kid, and actually ended up going to undergrad at SUNY ESF, which is an environmental science and forestry college up in Syracuse that also owns 700 acres up in the Adirondacks, and uses that as a classroom and a facility to study all sorts of environmentally related fields. And so my particular focus was ecological engineering, and that's sort of applying engineering principles to the natural world. And that I was lucky enough to have that really inform what I get to do for a living. Not everybody is that lucky, and I feel pretty fortunate to do that. For a while, I was working in engineering consulting before I came to Save the Sound. But my interest has been in these natural systems that was cultivated both through really play and my own interests as a kid, and then through scientific engagement in formal education. At Save the Sound, the program, historically, we partnered with local land trusts and other groups that would maybe their focus was a one-off restoration project in a piece of land that they may have owned. And so Save the Sound's role was to maybe bring resources to a project like that, but the projects were very different. It wasn't necessarily a barrier removal, dam removal wasn't necessarily always a component, and it really was dependent on the partners that we had on any individual project. And I was hired in 2010 after the American Recovery and Reinvestment Act, after the recession. Save the Sound was awarded a $2.5 million grant to complete two very large restoration projects in New Haven and in East Lyme, Connecticut, for the restoration of Fish Passage on the West River and Bride Brook. And so those projects allowed me to build relationships with some of our statewide restoration partners, and it really demonstrated a need to have a group of people that are able to take lessons that you're learning on one project and apply them to the next project. Land trusts and folks that are doing things on an individual parcel, that might be the only, that problem may exist one time on their particular piece of land that they're working with. And so sometimes those lessons that you learn through every project get lost. And so that's been, I think the size of the program now has really is a demonstration to how much of a need there was for that. So fast forward, we can talk more about ecological restoration, but fast forward to now, and we have a robust team of people that are working on a variety of different kinds of projects, both in ecological restoration, in like barrier removal and fish passage and living shorelines, and some of the projects that Alex works on, to our urban green infrastructure work, where we're focusing more on stormwater. But all of those projects benefit the Long Island Sound ecosystem, and all of them work towards the ecological restoration. And when we say that, what we mean is working with nature, is working with nature to restore natural processes, as opposed to restoring something in its form. So restoring function instead of form. And yeah, that's a little background on me and our program.
That's interesting to hear, function versus form, and it reminds me of your engineering training. Mm-hmm. And when we spoke recently, I had not realized you were an engineer, and that's quite interesting. And now in your role, I mentioned before soup to nuts, and what I meant by that, and you can articulate it better, but you're dealing with the upfront design, the execution or implementation, the qualifying and hiring of various contractors, subcontractors, and I understand you even get involved with helping potentially fund the projects through grants and so forth. Can you talk a little bit about that?
Sure. Yeah. So we are, I think that may be it's a really interesting part of this job. It doesn't, I mean, I think with many jobs, you're sort of working in one particular component of a project. And with this, we're kind of herding cats and working with each of the different components as you go along. So definitely, you know, our program is grant funded. And so we are raising funds to work on a collection of projects. And so every time we finish a new project, there's or finish a project, there's a new one that fills in, and that you know, compiled together forms our program. But in addition, so we're identifying projects and funding sources for those projects. Identifying and collaborating with design engineers and consultants to you know, put pen to paper and draw up design plans, or you know, in some projects working on those things in-house. Working with construction contractors to actually implement the projects, and our regulatory partners to permit them. We're also, and this is something that we've been able to get into more of, is our monitoring program. And so that is a component that if you know, there's just one or two of us, it's not possible to add in-house. But since our numbers are greater, we're now able to monitor and to talk about the results, ecological results of some of our projects. Yeah, Alex, you want to talk about that a little bit?
Yeah, let's bring in, I want to come back to the monitoring, but let's bring you in, Alex, please. First of all, hold that thought that Gwen was just asking you, if you could, and let's get to know you a little bit better. Clark University, correct?
Yep, that's where I started. It's where I remembered how much I just loved nature. I was on a different trajectory, I guess, and then was fulfilling a science requirement and realized that like this was my thing. It had always been. So after school, I went into sort of my first like career trajectory was kind of wildlife research, looking into like rare reptiles and amphibians, seeing the need for habitat protection and land protection. I moved into that realm a bit, and then from there, I kind of wanted to look at habitat management, so sort of some restoration of habitat types. But I think going back to what Gwen was saying, I sort of started to really see the need to protect and restore natural processes, especially in an age of climate change where we don't know where anything is going, particularly in terms of ecological outcomes. We do know that we need certain processes to be intact. So that's sort of what has pushed me into this field.
Yeah, when I met you a year ago, you had just come aboard, I believe.
Yeah.
So that was, you said that the Conway School is where you went back to, right?
Yep.
Yeah. Was that were you doing that while you were working, like a night school, or did you just go back full time?
It's like a 1-year intensive program.
Okay.
So I was not working. I was just at school.
Good.
And actually, another person who works with us was my classmate at the Conway School, Carrie White, who works on our green infrastructure projects. He was my classmate of mine.
Well, I was looking at your background, and the environmental track, really comes through. And that's a blessing that you were able to recognize that passion so early and pursue a career in it. So that's awesome.
Yeah.
I think Gwen was tossing the ball over to you to talk a little bit about, we were talking about monitoring and maybe one of the projects you're working on.
Yeah, sure. So we do some monitoring on projects that are complete. So we're removing dams for fish passage. So what we do is we then set a fish trap, a non-lethal sort of funnel. It's like a big minnow trap in the river. We set that upstream of the site and we monitor what is passing through. So we've been seeing on on the 2 sites that we're monitoring most readily, we're seeing alewife coming back in pretty big numbers. It varies year to year. It's just kind of a cyclical thing, but we're seeing good numbers. We're also seeing other migratory fish. Actually, just this week, on Whitford Brook out in Stonington, we caught our first American shad. So that would be the first American shad that was known to be past that particular dam site. I don't know in how many years, Gwen?
300.
Okay. That's pretty good.
Yeah.
So yeah, in addition to the migratory fish monitoring, we also work with Connecticut Department of Fisheries, and we monitor we go out and during the summer we monitor the resident fish communities to see if it's sort of reverting to or returning to a riverine fish community as opposed to a pond fish community behind that in that unnatural impoundment. That was a result of the dam, and we are seeing a return to the river community, and also the return of some species like brook trout, which is a cold water indicator. So yeah, it's like really exciting stuff. We also look at the vegetation that is recolonizing that impoundment. We did some surveys to see if that vegetation that's coming back is, just what the diversity is, and also what the like the wetland indicator status is of that plant community. And we're also working with a team from Yale, from the Yale School of Forestry, who's doing a much more in-depth sort of statewide study on how forests and other vegetation communities are regenerating on these former dam impoundments post-removal. So yeah, that's sort of a broad brush of our monitoring, I'd say.
How do you monitor the fish? You were just how do you do that?
Oh, the fish communities?
Yeah.
So it's called electrofishing, which is exactly what it sounds like. It's a standard method that fisheries staff uses to sample a stream reach. So they walk through and they've got these wands, these electric backpacks, and then wands, and it sends a current through the water. It stuns the fish. You scoop them up, you put them in a bucket, and then you count them, and then they wake back up, and then you let them go. So it's a pretty standard fisheries sampling method, and that's how we do that.
And what about, you mentioned a fish trap. It sounded like it doesn't actually trap it and keep it in there, or does it?
Yeah, so I'm using my hands. There's a river behind me. So it's like it funnels into like a little basket. The fish go in there, then they can't swim out. And then you scoop them out with the net and you count them, and then you throw them back, but past the trap. So then they continue swimming upstream to whatever spawning habitat they were pursuing. Mm-hmm. So yeah, that's the other fish sampling method.
Okay. Interesting. So maybe let's take a step backwards for a moment and just, I know Save the Sound has recently decided on one name. You're a roll up or a combination of really 3 different organizations, and for a while you were using 2 names. Can you talk a little bit about the history and this recent development?
You want me to tackle, or you want to do it? The other way.
I haven't been around quite as long, but I'll tackle it. Yeah. So, oh, there we go. Yeah, we used to be Connecticut Fund for the Environment.
Hey.
Yeah. That's a collector's item now. Yeah. So yeah, Save the Sound. We've been around for 40 years. We focus on sort of region-wide environmental action. So we're looking at fighting climate change, protecting important landscapes, and then of course protecting and restoring our waterways, the sound as well as the freshwater systems that feed that sound. And we do that through a series of different methods. We have like advocacy and outreach just to normal citizens, and then we do also legal action if that's needed. We have a pretty big program for water quality testing known as the Unified Water Study that looks at water quality in the embayments around Long Island Sound. And then there's the physical restoration projects that our team works on. So that's the dam removal, barrier removal, fish pass, like fishways and fish ladders, the green infrastructure, marsh restoration, and all of that.
Okay. So. Yeah, thanks. I know, and there was actually a third organization some years ago, the Soundkeeper.
Yeah, I can add to that. So the Save the Sound went through a pretty robust survey and branding effort with both with our members and with the general public to talk about a unified name. There's really been a need for one since the Connecticut Fund for the Environment and Save the Sound merged in 2003. But with the addition of Soundkeeper, it became even more necessary. So Terry Backer, who was the original Soundkeeper, was really a huge advocate for Long Island Sound and a state legislator. And he passed away, and prior to his passing, he and Soundkeeper as an individual entity sought out another organization to adopt the nonprofit. And so, with his blessing, Save the Sound adopted the Soundkeeper program, and now we have a Soundkeeper on staff named Bill Lucy. So a Soundkeeper is a person as well as the entity and part of the Waterkeeper network, which is an international network. And so we retain those connections and a boat named the Terry Backer, but now under a unified name of Save the Sound. And that was far and away the choice by both people in inland systems in New York and Connecticut for what was name really resonated with people and seemed like the most something that most conveyed what we're doing. And so, I mean, I've got to say from a personal end, it really feels right to be able to very succinctly say what it is that we're trying to achieve. So we're happy with that.
Great. Yeah, I think I definitely remember Terry. I think he started, I can't put a year on it, but when I was a kid, I think he started. And if I'm not mistaken, he was out of like the Westport or Norwalk area.
That's right. Yeah. Yep.
I thought it was a really cool effort and a cool guy. I never had the chance to meet him, but he did some good work. So let's get back to nature and talk about the work that you all do. I guess I'll let you pick what project area you might like to share more about with us, at least to start.
I don't quite know where to start. We're working on so much. Maybe could I give like a quick rundown of just projects that we have ongoing?
Sure.
I'll be brief. So we've got a fish ladder installation, also known as a fishway, going on the Farm River in North Branford. That's for migratory alewife and other species to get over a dam. We often take out dams, but when there's not that opportunity, we might pursue another option, such as a fish ladder or technical fishway or a natural rock ramp. So we're working on that. We've got a few dam removals in the pipe that we're working on. There's one out in Fenger Brook out in New London. That's a really small dam. That's like 4 feet high. Really tiny little pond. We're working on taking that out. We're also looking at the Dana Dam in Merwin Meadows Park on the Norwalk River. That's a much larger dam. Still a pretty small impoundment. Again, for migratory fish and the restoration of sort of cold water habitat through that impoundment, which will soon be a free-flowing channel with floodplains and floodplain wetlands sort of abutting it. We've got some fairly large-scale green infrastructure projects. We've got one that's going in the Hamden Town Center Park. That's going to be what's now just a soggy field is going to be restored to an actual wetland to sort of filter stormwater that's running off of a site, as well as creates a little pocket of habitat in a park. We've got some really small stuff. Residential, Gwen and I were actually both digging up sod earlier today on a residential rain garden. So that's just essentially going to a number of houses in a priority watershed in the town, in the city of New Haven, and disconnecting downspouts that go into the sewer system and directing that instead to a small depression known as a rain garden to infiltrate that water and again create a little tiny piece of habitat with wetter soils, vegetation that grows in that area. We plant native plants for pollinators and other species. We're in the middle of monitoring season, so we're checking traps every day. And yeah, that's a sample of what we're working on currently. I don't know if you want to delve into any of that or if you want to talk a bit more about future projects that we're also looking at.
Well, it's interesting hearing about the stormwater. So you're actually creating a mini habitat, but you're also, the effort is to prevent, even if it was a small number of houses, from that water going out into the sound. That's the ultimate goal. Is that, am I on target there?
Yes. There's a number of issues with stormwater. I think the issue in that particular neighborhood is a combined sewer overflow. Gwen, is that right in the West River? Okay. So some older infrastructure, some older sewer infrastructure combines the water from the storm drain, so the water from the street and the water from your house into the same sewer system and treats it all, which is fine if there's not too much water. When there's too much water, that overflows and all of it dumps out untreated into waterways. So that's one problem. That's what's known as a CSO. So in that neighborhood, what they're trying to do is, or what we're trying to do is remove any water that doesn't need to be going into that system, send that into the ground instead and have it infiltrate the soil, which is how it naturally would be. That would be the natural hydrology anyway. And there's a lot of benefits to that just in and of its own value. When water runs off of a surface, off of pavement, it picks up dirt and debris and pollutants, and it gets warm and it washes very quickly into streams. So it's polluted water. You can imagine a lot of water rushing in all at once. It's very flashy, so the water is like really high and then it's really low, depending on what's happening, through precipitation. But if it's infiltrating the groundwater and seeping through more slowly, it's getting filtered and it's creating a more steady hydrograph. So yeah, there's ups and downs, there's highs and lows, there's floods and droughts, but it's not as, the swings aren't as wide. So that's kind of the idea, one of the ideas behind a more restoring these natural systems through green infrastructure. Did that answer your question?
Yes. No, that was good.
Maybe more so. I'm sorry, I kind of went on a little
Oh, that was good.
Okay.
And I've heard you use the term urban restoration. Would that fall into that category, or is urban restoration something different? Like when I hear that, I'm thinking of, some of the cities where there's rushing water, just in the scenario you talked about, but instead of a local community of houses, it may be sidewalks and streets, and it's ultimately trying to get down to the river and into the sound. So that's a larger scale project. Can you?
Yeah, so this project, I'll use New Haven as an example community, but this could exist in a variety of communities. There is, an urban downtown area that's very heavily paved, and then really a lot of paved surfaces quite far into the residential area, and then eventually once you get uprivers, upstream, there is actually a lot of water company land and more forested and less dense development. So as you're going from north to south, you're running downhill, and water is collecting pollutants and picking up speed, frankly, and then discharging into the rivers and waterways that feed Long Island Sound. Alex described the combined sewer overflow problems that exist, and so that's untreated sewage also discharging right into our rivers and then into Long Island Sounds. But urban restoration doesn't have to mean one project in one downtown city streetscape. And in fact, one of the problems with urban water management is that separating those sewers, those combined sewers, would require digging up some of those really intensely, heavily trafficked and used city streets, and digging up pipes that are maybe made of brick that have been under there for 100 years or more. And so an alternative to that is filtering and managing and filtering water where it falls, rain where it falls. And so New Haven is really adopted that in a major way. So there are 200 bioswales, which are these curbside rain gardens that are a little bit deeper than a rain garden, right? So they have this well, and in New Haven, they're sort of 5 feet by 15 feet in the tree belt. And they capture and filter rain from the street and are planted with plants that are okay with having their feet wet, but are okay with being dry, and are used to some sort of semi-harsh conditions. So maybe a little bit of, the salty, maybe they're a little salt tolerant from road salt, and okay with some of the pollutants, and maybe even break down some of those pollutants. And the benefit that has, has huge water quality benefits, right? Because the water going through is not picking up pollutants, and it's all filtering into the ground instead of going in a pipe into the river. But it also has these water quantity benefits where you're not having, it's actually helping to alleviate the amount of water that we're getting downtown in our most urban centers. In New Haven, it's actually at the train station. So one of the major reasons for this citywide effort was that the train station experiences flooding, and it was experiencing more and more frequent flooding as time goes on, and we're seeing more significant rain events. And so instead of demolishing the train station or doing something at the location of the train station, the decision was made to do these distributed projects throughout the city, and they together, in summation, help alleviate that problem. But the bioswales themselves and the rain gardens that Alex and I were digging today, they are still in the urban city. They're within the city limits, and in areas where often there are not a lot of green spaces. And certainly if you're a migratory bird or a butterfly, there aren't very many opportunities to stop off and eat and pollinate. And so they create these little pockets of native plants that exist in a sort of a patchwork throughout the city. And Save the Sound's role in this part of the watershed has been to take that model and move it into the private land. So the city is working in the public right of way, and doing a huge number at this point. And we were involved with those at the beginning, but now they've got that part right. So they've tested that model and they're willing to implement them at scale. But what they are not as prepared to do as we are is to cultivate partnerships with private homeowners who would be willing and interested in green infrastructure and stormwater management, but that's not within the city right of way. So that's our role in this sort of citywide effort to manage stormwater in this greener way.
Okay.
Yeah, I think just to follow up on that, I think it's not intuitive for most folks, and it's hard to believe that like what you could do with the water coming out of your downspout on Royden Ave in New Haven has anything to do with the cleanliness and the habitat quality of the sound. But it really does. And I think like, if everybody did a little tiny bit throughout that area, so again, as Gwen was saying, that distributed impact would make a big difference, because the problems that we're facing with stormwater and other environmental issues is it didn't all happen at once. It happened little bit by bit. More houses were built and more, the processes were disrupted bit by bit, and now we're sort of working on bringing them back bit by bit also.
Let's switch gears and talk about dams. Alex, when I met you, there was a screening of this film, and somebody asked how many dams there were in Connecticut, and I think the answer was about 4,000. And I notice on your website, it actually says about 5,000, maybe more than 5,000. And that's shocking. But then you think about the history and how many dams were built for industrial purposes, for power, and of course, very few of those are in operation anymore, yet they still exist, and they impact the water quality, they impact the migrating fish, they continue liability to the dam owner for any sort of downstream or upstream flooding. And they also need to be repaired and inspected. So I wonder if you all could elaborate on some of those thoughts and why dam removal is important to save the sound.
Sure, yeah. I'll say when I was growing up, only when I came to realize the issue with dams did I come to understand that every pond or lake that I swam on or fished on or played at as a kid was a dam, was an unnatural pond created by a dam. I grew up in Eastern Massachusetts, which had a very long industrial history, and we take for granted that a lot of the ponds and lakes that we see are from a dam. And like, it's not the Hoover Dam. They're these little stone dams that are sort of scattered all through the watersheds of the state. So yeah, they're everywhere, and it is kind of a shocking number, but once you start to notice them, it becomes pretty evident. So why do we take them out? One reason that everyone thinks of is migratory fish. They think of salmon, which swim, upstream into shallower waters where their young have a better chance of, surviving and then swimming downstream back out to the ocean. So migratory fish are a big part of it. And some of the migratory fish that we focus on here are alewife, which are a forage fish, a feeder fish, a bait fish, essentially, that is a huge source of food for other species in Long Island Sound, as well as in the Atlantic. And then also their young are a source of food for the freshwater species and predators that are in the streams that they come in to spawn. In addition to these migratory fish, there's also a lot of other species that just need to move up and down the river corridor in the course of their own life history, even if they're not going out to the Sound. So that's just sort of, ecological connectivity. That's really important, and we're really trying to restore that, especially, as I said, in climate change. We know that things are going to need to move. As habitats are changing and becoming degraded, they're going to need to move up and downstream to escape this degradation, find cooler habitats if that's what they're looking for, and things like that. And then there's another component, which is sediment. People think of water, but what a river also does is it moves sediment downstream. And that sediment, goes out into the estuaries. It forms the basis for tidal marshes. It also creates different habitat structures and different habitat types on the riverbed below. So restoring that natural sediment transport is a big part of it. I could probably go on, but Gwen, do you have anything to add about reasons to remove dams?
Always happy to talk about reasons to remove dams. Alex summed it up. I think I would add maybe why remove dams as opposed to focusing on another type of ecological restoration. And a dam is this permanent blockage, like a blocked artery on a river. And once you remove it, it doesn't come back. And so it sounds silly, but when you think about invasive species, or you think about maybe introducing an extirpated species, that cultivating that restoration practice is, maybe completely valid, but once you leave, you don't know what's going to happen there. It requires monitoring and maintenance and ongoing cultivation. The one thing that that dams have, this dam removal has this permanent restoration of ecological function on the system that we're working in. And so you're allowing the river itself to establish a path and restore the hydrologic function that forms riverbeds and forms new ecosystems. I say new ecosystems because something particularly in Connecticut that was in our history were these disturbance events. So disturbance events like fire, and then following that, disturbance events like people cultivating land. And so one of the habitat types that's fairly rare is we kind of stopped a lot of our agricultural practices in the state at the same time. So the forests in Connecticut are a very similar age. And so one of the things that dam removal does is it mimics these disturbance events that are fairly rare in what we're seeing now. And so there's a different, this sort of shrub habitat and wetland complex that exists right after a dam removal, is a unique habitat type, and has been of interest to our academic partners and I mean us as well, but is another really big benefit of dam removal.
Great. Well, I know we could go on further with this topic, and I'd also, I think we're going to have you come back, and we'll talk more, because I'd like to talk about your work with coastal resiliency too, the living shorelines. But I want to make sure we have time for our audience to ask some questions. I'd like to just end this segment by asking you, we always, our audience always likes to know what they can do, and you've sort of touched upon that in a way, but could I ask each of you what people can do to make a difference? What sort of action might they be able to take?
Do you want to start?
I think, I mean, they can literally start in their own yards. I mean, that's kind of what we're seeing with our, our distributed residential rain garden program, is just thinking about the water that falls onto your roof. Where does it go from there? Does it infiltrate into the ground? Does it flow into the street? Does it go into a storm drain? And then where does it go from there? I mean, that is something you can literally do in your own backyard. There's a lot more people could do. I mean, Richard, after you and I met, you got in touch with us about, some potential projects that you had in mind. Other folks that we meet through events like this, they reach out to us and say, hey, there's a culvert that's perched in my neighborhood, or, this would be a great spot for a rain garden. That just, being aware of the types of practices that are possible, and then reaching out to folks that are doing it like us can be like a really good way to sort of advance the things that we're working on.
Yeah, if you being observers in your local ecosystems is the state right now compiles a weekly diatomous fish report, and so they collect data from all the different rivers in the state. And if you were to see fish at the base of a dam near you, then that would be perhaps a reason to consider, pursuing removal of that dam. And so if that is often how we find projects that we're working on. There's, I mean, there's an element of, you know, we work collectively with partners, restoration partners around the state to prioritize what projects we're going to work on. But I would say really the most important part of that is having a willing and collaborative local partner. And so that is that's something that, you know, all of you could think about as you're sort of exploring your local rivers. I guess we're also the International Coastal Cleanup coordinator for Connecticut. So for those of you who live in Connecticut, if you're interested in participating in that, as of at this point, we're planning on holding International Coastal Cleanup Day in September. And so there will be, last year there were 70 cleanups all around the state, all, you know, within maybe a month period. And that was an opportunity to keep plastic out of the world's oceans, and you know, get people outside and you know, participating in their local ecosystem. And it's something that, you know, is an activity that could happen solo if it needs to. So we'll likely still have that activity up in September.
Yeah, that's great advice, Gwen. And that's something I'd like future Frogmen to get involved with as well, your International Coastal Cleanup. We are, this was to be our year of action, and we've run into an obstacle with the COVID-19. We had started doing monthly coastal cleanups, and we executed in January and February, and then we had to stop in March, unfortunately. But we were attracting about 50 students, and we had really great turnout and a lot of fun and a lot of productivity, and unfortunately a lot of trash, but it was all cataloged and submitted to NOAA, and we'd love to work with you. And by the way, if anyone's interested in learning more about us, just check out our website, futurefrogmen.org. And so let's shift over to questions. Thank you so much for your great information there, Alex and Gwen, really wonderful. We have a question here. Folks, you can unmute yourself and ask your question or enter it in the chat box. I have, I'll read off a couple that are in the chat box here. One is, are there lessons from recharging groundwater in big, densely populated cities worldwide?
So we actually, would you like to? I can talk about a project. So the Quinnipiac River, there was a Superfund site on the Quinnipiac River, and one of the impacts was to a drinking water aquifer, and so we were funded to install a number of rain gardens in that would recharge the neighboring aquifer. So the intention was to recharge more groundwater in the adjacent aquifer that had not been impacted by the Superfund site, as mitigation for the impact, and that was funded by the PRP, by the responsible party who had polluted that aquifer. That is something that's being thought about on a large scale, is trying to get water back into the ground. So in really dry environments, and there's, you know, we have to move beyond putting clean water into our storm drains. And that's another reason why this green infrastructure isn't just right for places that have combined sewers. It's needed in places that have separated sewers too. We really need, you know, to be thinking about putting clean water back in the ground before discharging it as one point source into a river. But that can be scaled up, and is honestly being scaled up in places like Las Vegas and San Diego, and South Africa is a big one. I don't know if there's, so they actually were supposed to run out of water. I can't remember, it was about a year ago now, and they managed to cut their use by 50%, and then were able to recharge their aquifer, and so have extended their that timeline significantly. Now they're not done with the problems, but it's shown how possible it is for big cities to think about recharge.
Yeah, I was gonna say, I don't think it's based on groundwater, but I know that New York City and Philadelphia are just a couple like large cities in the area that are have implemented this green stormwater technology. These like, you know, these small distributed bioswales throughout their city, you know, not just because they're very functional at getting a lot of water into the ground as opposed to into storm drains. So yeah, definitely look into those cities and see what they're doing.
Thank you. That was definitely informative. Thank you.
We have a question here from Anthony Zamba, and it's
Hi, Anthony.
he's got some upfront statements, so let me just read it to you. It says, Gwen has also served as a rotating member of the Connecticut Wetland in Lieu Fee program for 3 years. Thanks, Gwen. The program could continue to benefit from Gwen's and Alex's expertise through information sharing. We have reached out to NGOs, consulting firms, and regulatory agencies to gather data on costs for stream restoration. Any data that STS or others could share with the ILF program would help make our data set more robust so that we can better assess, justify the credit fee for linear foot of stream impacts. So kind of a statement, but I guess a question about any possibility of data sharing.
Can I ask, do you guys have a credit or a fee? What is the current cost per linear foot? Do you know?
Yeah, so right now we've been using $100 for $200 for per linear foot for intermittent water courses, and $600 per linear foot for perennial water course. So that's the 200 times 3, one for each bank and then one for the stream bed itself. So those
And how
numbers,
does that compare to what do you have for wetlands? It's like
the wetlands, it's based on cover type and service area. So the stream credit was basically just adopted by some of the previous ILF programs that were around. And so, you know, we don't even really know if it's enough to fund restoration projects in Connecticut using Connecticut economy prices. And what we would like to do is adjust that one way or the other to make sure that it's enough to fund restoration, but also not make it so that it's prohibitive for the sale of credits.
Sure.
And we know that, you know, every water course has so many different variables to consider, and that it impact cost. And so really the only way that we can approach it is to build a big enough, robust enough data set that we could average out those costs across all those variables. And knowing that, you know, sometimes, you know, the fee will not be able to generate enough money to cover certain types of restorations, stream restorations through the grant process, but other times it will. And oftentimes the people applying for the grants are matching it with other funding sources. So we don't necessarily have to cover the cost of every restoration project, but be able to, you know, on the average, be able to do that.
Yeah, thanks, Anthony. I don't have a response to that right off the top of my head, but we could certainly get you some data related to that.
Yeah, and that's been the response from everybody. It's like,
yeah,
really taking the time to calculate out the cost.
right. So you would need cost of projects and the linear feet of restoration, right? Those
Exactly.
are the two variables.
Just, yeah, divide those numbers. Yeah. Yeah.
Okay.
So for like Pond Lily, I know there was a dam removal,
Yeah.
but also, you know, stream restoration that you had to take into consideration, both upstream and downstream, right? To prevent like head cutting and, you know,
Sure.
have you get the gradients right, and planting, perhaps, all those things come into play. And, and design and permitting costs too.
Right. All right.
Well, great. Thanks for your question, Anthony.
Thank
Gwen,
you.
Alex, Anthony's email is in the chat box if you need it. And I can always provide that to you afterwards if you like. And we have one more question here. If anyone else has one, please let us know. But I'll read this one. It's a three-part question about dams. What kind of obstacles do you encounter when removing dams? How does it get funded? And what percentage of dams in Connecticut are now obsolete?
You want to take it? You want me to? I don't have-
An obstacle to dam removal can be sort of cultural, surprisingly. Lots of folks get used to the pond that's either in their backyard or in their town center or just in the woods that they like to visit. So there can be significant pushback from people who they like the landscape being what it is. I mean, I was just commenting on how all the ponds that I grew up on are all dammed ponds. So that can be a significant hurdle. Another hurdle is your second question, which is how does it get funded? Gwen was speaking earlier about how a lot of the money that a lot of the projects are funded through grants, federal grants and other grants. A lot of times grants need match. So you might get, you might have to match what the federal government gives you by 50% or 100%. And that can be either in kind, like services, or actual cash. But yeah, getting the money together. I think what Save the Sound brings to the table is a lot of experience, like what Gwen was saying, with all these different components. So managing the contractors, managing the consultants, managing the permitting, and managing the grants. So there's a lot that goes into it, and there's a lot of moving parts, and they all have to kind of get lined up at the same time for that to sort of happen.
Yeah, just to plug one of the potential funding sources is what Anthony was just describing, which is the in lieu fee program. So if there's impacts to a river by the Department of Transportation or others that that a dam removal could be considered as mitigation for that activity, and that's one funding source that is somewhat new to the state of Connecticut. The Anthony's program that he manages with the Audubon is been around for a few years at this point, maybe 5. Is that right? I think so.
Any idea on?
Sorry, I was muted. Since 2013.
Okay. Yep. So,
Hey, Richard.
oh, and what percentage? Okay, percentage of obsolete dams. So I have so the discrepancy for number of dams in Connecticut has to do with number of registered dams versus number of barriers that we think might exist in the state. So we know that there are over 4,000 dams, but that's as close as the state has as a number for what how many dams there are. But of those, there are 40. Oh, okay. Yes, there are 40 state and federal flood control dams in the state. 400 municipal or nonprofit, so municipal or land trust owned dams. 264 dams that are owned by the Department of Energy and Environmental Protection, and 3,696 privately owned dams in the state of Connecticut. And so that's, well over 3/4 of the dams in the state are privately owned. And so while that doesn't necessarily mean that all of those are quote obsolete, it does mean that there isn't someone who's being paid to keep them and maintain them. So some of those might be water supply, but the vast majority of dams were constructed in an industrial time with a miller. And the millers had their livelihood, and their livelihood was tied to the operation and the function of the dams themselves. And that just isn't true anymore. That changed significantly with the Industrial Revolution. And so there are plenty of dams that could be removed without tackling or considering to remove things like Candlewood Lake and other things that you might think of, or flood control structures. The Tolland Flood Control Dam. There are dams that serve purposes that are a part of our existence as people, as part of ecosystems. But particularly in the Northeast, there are many dams that don't fall into that category. So hopefully that helped with the numbers a little bit. It's not quite the percentage, but.
I look forward to having you come back and continuing this conversation. And thank you, audience, for joining us. If you're not a subscriber, please visit our website and sign up so you can hear about our ongoing conversation series and check out other things we're doing. It's futurefrogmen.org. So Gwen and Alex and audience, thank you so much. And we look forward to speaking with you again.
Thanks for watching. For more information, visit our website at www.futurefrogmen.org.